All right. Well, thank you, everybody. Thanks for letting us come in and hang out for a little while and letting us chat about Meshtastic. This is something that we kind of started down the journey of, honestly, like 2 years ago now at this point.
Yeah.
And we just kind of got ourselves some nodes and just kind of started poking around with them to see what it would do. And we kind of put a lot of effort into kind of figuring out what these can do. We just kind of want to share with you guys a little bit of what they are. This is very much a ever-changing project. It's very much still in development. So some of the things that we'll go over are still actively being built, and like they're always kind of fixing and adding and changing to the features and those sorts of things. So you might find that something that might not work right now might work great in a month or two. So there's a lot of just moving and changing as far as all of this stuff goes. So we're gonna get on in to what we got. So why Meshtastic? It is a well-supported and documented protocol. It uses the LoRa protocol, LoRa, which works off of basically a flood routing method. So all the packets kind of go in and then splash back out. Being a decentralized mesh, it's self-healing and highly available. The hardware is relatively affordable to very affordable, depending on which ones you get. There's the opportunity, which most commonly do have AES 256-bit encryption, which is the regular standard of modern day. There is enterprise-grade security and remote management features, and it also works for iOS, Android, and for computers as well via the Python libraries and or via the web flashers. Meshes of the past. For any of you who have gone down the rabbit hole of AT&T long lines, as a network guy myself, that's something I enjoyed very deeply. So, this is a mesh network at the end of the day. Mesh networks of the past, they used more power than these guys have, 5 to 20 watts, or, roughly 50 to 100 miles apart on much bigger antennas with much more budget than what we're kind of working on now. But of course, as we all know, a mesh is just going to be nodes strategically placed, meshing over to other nodes that are strategically placed, and then connecting back down to you by just flooding all of the packets out. So that way you kind of hear everything. So from an efficiency perspective, it can only be so efficient. So the packets are usually going to be a bit smaller and such, but the mesh is the best kind of functionality for what we're going to be working with. So what is it for? A couple of the things going to be secure messaging. As I mentioned earlier, that the messages are often AES 256 encrypted. You can kind of turn that on and off, and it depends on what you're trying to send for what you're getting across it. But in general, they are encrypted messaging. There's other PKI kind of options as far as like managing the devices with public and private keys. Of course, it is an off-grid network, and location sharing is a big one as well. A lot of these nodes, they either come with or can add in like GPS modules and such to it. And say that you're off for like hunting trip, for example, and you're just like out in the middle of the woods. You can kind of keep tabs on your buddies where they are around with you. And again, with just low power and just very light and cheap.
Something on the side.
Go ahead.
So this picture right here, the off-grid network diagram, the green are like public nodes that people use, pieces of infrastructure, and then orange is private nodes. You and I, if we're just trying to have a private conversation. A really cool part of Meshtastic is we still benefit from the public nodes with our private traffic because the nodes don't need the encryption keys to repeat. They're just going to repeat any packet they get, whether they can decrypt it or not. So let's say we all have a node and only 3 of us are on the same channel, the same key. If person B goes to send a packet, even though they don't know that node, they don't have the encryption key, that node is still going to help in the bigger mesh. It's still going to forward those packets on. You can turn that off if you don't want to be part of that. But that's a really big piece of Meshtastic is the more nodes, the better. Even if you're not friends, even if you haven't shared encryption keys, you can still use their piece of infrastructure to get your messages across.
It's very similar in nature to APRS, if only APRS had sort of like private chat rooms, so you can channelize it, so you don't necessarily have to be flooding everything to talk to your buddy.
And like we're only going to kind of hit the wave tops of what this can do. Most of the stuff is going to be on like frequency slot 20, but there's a bunch of different frequency slots kind of along the along the band here. This is 900 megahertz ISM band. So there's a decent amount of bandwidth available across there. And like most everything that you're going to see is on like the primary channel, channel 20. So like if you wanted to be, extra private, if you will, you could even move to channel 19. And as Davey said, you won't be getting the benefits of the same public mesh, but then you'd also have your own private infrastructure if the public got too busy or something, for example. Some of the options of hardware, especially for mobile devices in particular, are going to be the rack boards. Thank you.
Do my best in band of life.
These are the most common and prolific around. As you see, they're only, and with the antennas not dangling off of it, they're only, this big. These guys use very low power consumption. This guy runs off of one of those boards. I believe this is 3000 milliamp hour battery. And this guy lasts with GPS and other sensors and screens on it, lasts the better part of a week. This guy in here with a little solar power on the front of it. And these ones I specifically put in two 3000 milliamp hour 18650s. And that can run for a better part of 2 weeks, up to 3, depending on what sensors are on this specific node, how often it's chirping out, that sort of stuff.
And with the solar panels, it's essentially that all of our routers are built that way up on mountaintops, and we only have to go up to them for maintenance.
This is like a budget one. This is a Harbor Breeze solar light from Lowe's. It costs $15. You get the solar panel, an 18650, and a nice enclosure. And I've had this one out for the better part of a year on my roof line, and it's just powered itself. It crashed eventually because the firmware got too out of date, but it just kind of self-sustained the whole time.
And like nothing here is $100.
No. Yeah, the boards are 35, the racks. So it's pretty cheap to kind of deploy this stuff.
Yeah, so the racks are what we're going to go into the most of, and what you're going to see the most of. Heltex are the next example, which is this little guy. Those are definitely like where this rack will last roughly 7 days on a battery. What would you say the rack is? 2 days on a equivalent?
Yeah, probably. It eats a lot more because I think it's ESP32 for like the compute chip, and the racks are something way more efficient.
NRF52.
There you go. So yeah, the everything else kind of eats the batteries, but the racks really set the power. So that's why we kind of use those for their remote deployments.
Yeah.
Also have Bluetooth. Yeah.
Yes.
They all have Bluetooth.
Yeah,
Yeah.
rack doesn't have Wi-Fi or you can add in GPS, but it's a separate little like $2 module that clips on the back. Okay.
This one's the T-Beam, which is the last one on the list, and it has good features like Wi-Fi capability, but it's very power hungry. Like this will last maybe a day if I don't plug it in, and it's kind of sitting there idling. Like this sits on my desk and it's always plugged into power. So.
But also these guys, they come with GPS, they come with Wi-Fi, they come with other abilities as well. You can put little lights and other things on the GPIO pins, that sort of stuff. So whereas the racks, they also have a full sensor suite. The routers that we deploy will usually put a little temperature sensor and like barometric pressure thing on there, or temperature and humidity, but barometric pressure is one of the options. So then we can just kind of on the default like long fast channel, we can actually see what the weather looks like up where our repeater is. So it's kind of a cool ability, just kind of gets your own little off-grid weather map as it's going along. And
there are plenty more sensors you can put in. So you can do light sensors, switches, you can wire up all sorts of different projects. If you want to do, say, see when your mailbox is open and closed.
Yeah, these boards, these rack boards, they like specifically this like specific one is, somewhat made for Meshtastic, but it's a whole ecosystem. So like these racks, you can do a bunch of other things with unrelated to Meshtastic specifically. The ESP32 chips, similarly, like you have
I've built like a little 2-meter transceiver out of them. It's kind of like Raspberry Pis where you can kind of program them to do anything.
So lots of different options there to kind of meet different use cases. And then we kind of get over to the base station side. So oftentimes these will be more mounted on your house, less so as much as the repeaters, because as we said, if you're up in the middle of the woods, you don't have the more power hungry amounts of power available. So like these guys, for example, the Station G2 is one that I'm personally very excited about. And we have some coming in hopefully by the end of this week if all goes well. But these, like the Station G2 specifically, provides a lot more power availability, upwards of 4.8 watts. Now, technically for the ISM band, for the encrypted traffic, because ISM is shared with our 33 centimeter band, we as hams, which I'll get into later, have the ability to use more power, but the default, just like generic rule, is 1 watt of power. But the Station G2s have the ability to get up to 4.8 to kind of overcome some coax losses and other things as well. I forgot to mention that these guys are very low power, so these are like more like a 1/4 of a watt. So it really matters for your elevation.
Yeah. Like even with like LMR 400, if you have say 10 feet of feed line, you lose basically all of your power out of that.
Mhm.
So it basically for the little guys, you more or less have to have it mounted straight to the antenna.
Yeah, so the Station G2s are a really good workaround for that. They're powered off of USB-C PD. They're ESP32 based, so they're very common on that front. And they also have a collection of sensor ports available as well. So that's something we'll definitely be learning more about here soon. And we're very excited to mess around with. I know that I am not in a terribly good RF area because my line of sight is not terribly good. So a little bit of extra power will make a pretty decent difference for myself. Signal amps, of course, we know everybody loves a good amp. There's definitely options out there. They kind of change the amount of output depending on the amount of feed voltage coming in. I don't know if I want to put one on a on a spectrum analyzer and actually see what it looks like. You may or may not, but just something to call out there. And then, of course, yeah, our different types of antennas. Depending on what you're doing, I think we have anywhere from 3 to 8 dB gain antennas kind of in the world that we would be potentially using depending on your potential use cases. So
In this 915 megahertz space, there's a lot of products online of antennas, and a lot of them are garbage. So of course you guys are hams, so you can, check the SWR of your setups and things, but there's some trusted vendors. Rockland Alpha is one of the really nice antenna vendors for this space, but we've seen some garbage stuff too on
Yeah.
Amazon or whatever. So
Yeah.
being selective about the hardware is key.
I poked a lot of the cheap ones with my Nano VNA, and it shows like it's not even meant for 915. They're like Wi-Fi antennas, they're just being rebranded. So even like when you buy the T-beams, a lot of the little rubber ducts that come with this are actually just Wi-Fi rubber ducts, and they get like a 4:1 SWR 915.
Yeah.
So
yeah, so just
buyer beware.
Yeah, just like any consumer hardware, having the extra abilities to kind of tell what's good and what's bad. Writing an Amazon review will go a long way for some other folks that don't have the access to the same tools. So something to keep in mind on that front.
The majority of nodes we're using, like we said, are these rack wireless little $30 ones, and they sip power. It's 4 to 6 milliamps per hour. The node we've had up the longest, so I put up last winter, is in Leamington, and that's been running off a little 2x3 solar panel and a single 3000 milliamp LiPo pack battery. And except for this spring, when all the trees flushed out, we realized we'd put it right in the way of a maple tree. It's been running fine, and we moved it to a sunnier area, and it barely dips below 50% power in the middle of the night.
I've never seen it below 90.
Oh, nice. Yeah,
Yeah.
I haven't checked in a while. So it's the sort of thing where if you're building a node like this, either for your house or portable, and you're using one of the rack wireless, a couple of batteries, and the companies that sell these typically sell matched batteries and things like that all as a kit. It'll last you forever. And like we said, the more powerful ones, so the T-beams and all the others, do draw a lot more power, but compared to 2-meter radios or anything like that, it's still basically nothing. Instead of walking around with a Walksoon and all the stuff to do APRS, this fits in your pocket and run all day off a single cell. I put in here too, running these off solar is very easy to do. We've repurposed outdoor lights. Rockland, who sells all these parts, also makes solar panels that are matched to them that have the right little JST connector on them. But you can basically run it off of anything. Same too, if you're running, say, a node in your car, you can just plug it into the cigarette lighter socket, and that's more than enough power.
Quick note on these as well is watch the polarity.
Yes.
Because connectors, there's not necessarily a standard polarity, and they're all marked on the boards and stuff, but just make sure you're matching the right polarity.
I've definitely never cooked one messing that one up before. Yeah, they are a little sensitive. I mean, you're dealing with a bare board electronic. Discretion is good, you know, ground yourself, make sure you're double checking your soldering, especially with the T-beams for their screens. They typically come and you have to solder the screens on, which is just to think like 5 header pins, but I've still managed to kill one doing that. So here are a few examples of different ways we've had remote nodes deployed. So for a lot of them, we just put together, you know, a waterproof cheap box from Home Depot like this, drill a hole for the antenna, pigtail, drill a hole for the solar panel, close it up, you know, judicious use of silicone caulking. And for my antennas, I typically wrap it in the conformal tape and then wrap that in electrical tape for UV protection. But they're pretty robust. And then if for bigger installations, particularly if you're using something more powerful like one of the Station G2s or one of the T-beams, you can see you have a separate external antenna and a larger solar panel. And then the last photo there is of, I think that's one of the Heltec.
Yeah, the pre-builds.
Yeah, if you don't feel like getting in and you know wiring one of these up in your kitchen, you can just get pre-built ones that are coming at a little bit of a premium. Typically, they just have a 3D printed case, but it's nice if you just want something that works immediately.
There's new rack ones as well that are pre-built on Rockland that just ship to your house. You just flash the node, put it in.
Yeah.
And they even make one, it's the Lily Go T-beam or whatever that has a keyboard built in, so you don't even have to tie to anything to use Meshtastic.
It's like a BlackBerry. It's kind of cool.
Yeah. I've been meaning to buy one of those. So here's where it gets a little bit more complicated. There are a number of different device roles that you can pick when you're setting one of these up. The first time you connect to a new node that you've just set up from your phone, say, it'll give you have to pick a few different settings. And one of them is the device role. 99% of the time you want to pick the client role, which is just a normal, you know, walking around client. That means that it will repeat packets that it hears, but it won't take precedence like something like a router would. There was an alternate one called client mute, which doesn't repeat packets. So if you have 5 or 6 of these things in your house and you have one up high in your house that's actually good at repeating packets, but then you have all other ones you're playing with, you want to set those to client mute, which means they'll still work in the network, but it just won't automatically repeat anything. That way, especially if you're testing things out, you know that you're actually getting out to the network and not just making a circle in your house. And then the other big one, of course, is router. And that's essentially the same thing as a client, except in the network, it takes precedence for repeating packets. And routers typically are the ones that you're installing on high places. So tower, mountaintop, things like that. So the ones that were screwing to trees on mountaintops, those are all routers. But unless you have a pretty good location, like you're up high on a ridge, your home node, you probably just leave as client. There are a couple others. There is now sort of depreciated one called repeater. That's the same thing as a router, except it doesn't transmit any of its own telemetry. So you don't really know where they're coming from, and you don't have anything like sensor telemetry or power or anything like that. Honestly, I think they're probably going to remove that from the software at some point, because it's kind of a holdover. And then there's also sensor and tracker, which kind of do what they say. Sensor is designed for getting telemetry out easily, so it doesn't take precedence for things like the communications, text messaging. And then tracker's the same thing, but just for GPS. So kind of like a APRS tracker. And here, so when you first set one of these things up and you download the Meshtastic app onto your phone, or you're working on your computer, right when you boot yours up and connect to it, you'll see this. And the sort of the most important things are highlighted. So region, obviously United States, that deals with frequency and a number of other things. So we're in the 915 band. There is the 400 megahertz ISM band that's available in the US as well, which Meshtastic can work on, but I don't think anyone's really using it. Everyone's kind of sticking with 915. And then Europe is 868, I think. And then, so obviously region United States and presets. So like you see on a lot of things like JS8 and FT8, there are different speeds of transmission. So the standard is long range fast, or long fast. And that is, I think we have a slide later with baud rates. It's slower than HF APRS, but faster than most other things on there. There are a few other different modes, so medium range and short range faster modes. Some groups like down in Boston are trying that out in dense areas. But here in Maine, long fast is a good standard. And then the other thing is frequency slot. So obviously that part of the band is divvied up into different channels. The standard for US is 20. So if you leave it on there, you'll be able to hear everyone else. If you change that, you'll hear yourself and anyone else has changed as well. And it's so sparse around here for nodes. We haven't had any real trouble with collisions. Even with the New Hampshire mesh is growing pretty quickly and they have a lot of nodes, but even then it's we haven't filled up the frequency slot.
And just as a note, if you change away from long fast, you also no longer benefit from the larger mesh. Because it's like the modem basically. So if you change the modem, it's a different kind of preset, so.
Yeah.
You
So
can't hear each other once you change it.
Right.
yeah, so if you're not hearing anybody whatsoever, double check those settings. Long fast, frequency slot 20 in United States.
We skip back one slide for a second. I didn't highlight hop count on here. Hop count's important. So when you send a message, it's a packet. That packet says, I want to go so far and then stop. And your packet is what controls that. So the default is like 3. And if you know, in Maine, we're a couple of repeaters away from each other anyway. So if it's at 3, your packet's getting dropped before it gets to the destination. 7 is kind of like the consensus between us and what we've seen online that works, but it doesn't propagate too far and kind of clog stuff up. Again, we're in Maine, we're not gonna clog anything up here. But so another important part on these LoRa settings is getting your frequency slot, your hop limit right here bumped up from the default 3.
Yeah, so it starts at 7 and then when it's repeated once, so like from my house to Dakota's, it'll drop down to 6, then it goes from Dakota's to one of our routers 5, and then they're on. We've been able with a decent, occasionally there are lifts, kind of like you have a 2 meter. We've been able to get down to Massachusetts in about 5 hops, so 7's a pretty good compromise. Thank you for reminding that.
That's the client view comes into play there. If you have 3 nodes in your house and they eat up 3 of your hops, you know, it's hard to get anywhere else. So
Yeah.
that's where client view comes into play too.
So if you're getting into this and you have, you climb up on your roof, and you put one good node up there, leave that as the client, then make everything else client view, unless it's your, you're walking around sort of thing that you turn on when you leave the house. Yeah, so this is a little bit, so we said encryption a lot. I know it's kind of a naughty term in the ham radio space. The encryption allows you to have sort of privatized channels, not necessarily because you're trying to hide anything, just so there is some crosstalk and cross traffic. Up to the 1 watt transmission power, if you have one of the ones like the station G2 that can transmit more powerfully, that's legal. It's an unlicensed band. There is, you'll see in the settings, a ham mode that enables over 1 watt of transmission power, but it also goes in and disables all the encryption functionality to be legal. It also, and I haven't messed around with it too much, you also have to put your call line in there, of course, and it transmits that with every packet, kind of like APRS does. If 30 milliwatts is good enough for most of the routers, going up to 1 watt will, you'll be burning the files out on the receiving nodes. Ham mode is available for anyone who wants to try, super long range or tying a Yagi to it or something like that. Yeah, so there's then also said before, there is a 433 megahertz option as well. And you can go out and you can find the same hardware, but just with a different radio in it. But I don't think that's really common. Also, the 433 is way busier in the spectrum. That's what tire pressure sensors use and cheap, wireless doorbells and all that sort of thing. So the 915 is a bit cleaner and a bit more effective. Let's see. Oh yeah, here we go. Feeds and speeds for the for everything. So this kind of puts you into perspective. So the third from the bottom there, long range fast. So that's just over 1 kilobit per second. So this is good for text messaging, and there are a few things that people have laid over on top of the protocol. So there's like an outdoor like EMS response sort of thing called ATAC that's popular, and that has a plug-in modem for Meshtastic to transmit over this. But you're not going to be sending picture data. This isn't like a voice mode. It's just text messaging and putting that into comparison. So I think the short range fast is about the same as like 2 meter APRS. So it's slower than that. And here I think David is my head off here. Yeah,
Sure.
yeah, fiscality of it.
Sure. So I was going to talk about kind of deployment, real world scenarios, and some troubleshooting steps. I probably like this early spring into the summer, we've kind of really hit the ground testing with this stuff in the field. And I think like anything, like on YouTube, it looks awesome out in the desert where it's all flat and there's no hills and you can see your buddy from 50 miles away. This works great. You get a 50 miles with it. Here in Maine with hills and terrain, you can get a quarter mile, 1 mile, or if you get up high above trees, you can get, longer, 20, 30, whatever. So I'll kind of talk you through how we tested that. So first, this is kind of talking about deploying a remote node like these here somewhere where you don't look at it all the time. Physical access to the device allows access to the encryption key. So if you can grab this and you can plug into the board, you can grab the encryption keys. When you deploy repeaters, like I said earlier, you don't need the keys to repeat the traffic or to route the traffic, sorry. So we don't actually have keys on these. They're the primary channel's long fast, which is the public one that everybody uses. And then it just blindly repeats the encrypted traffic that we're sending from our private channels or our direct messages. So, if someone steals your pocket node where you have your encryption keys, they have access to your communication channel. But if they steal a router and you haven't configured properly, they won't have access to your keys. Of course, you should only, share encryption keys in person, not over, the internet, Facebook Messenger, or whatever. This is where I'm talking about how it decides what to route. Read broadcast mode set to all forwards the packets without needing keys. There's also settings that's like known only, so it's only going to forward the packets that it has the keys for. You can use PKI admin to remotely manage these nodes over mesh. Let's say you have one up in a mountain somewhere and it's in 30-minute hike to get there. If you want to change a setting or something, you can do it remotely over the mesh. However, it's hit or miss. Dakota was talking about some of these features are new or they're not quite ready yet. I'd say this is one of them. I've tried to do some remote administration, and if I don't have like a really good line of sight, full connection, it fails out. I think what's happening is the traffic to pull the configs back over the mesh. It's a lot of data for it to do, and if it's not consistent, it'll drop out an error. So PKI admin's cool and it's a good idea, but it's still not quite there yet. Manage mode is another important thing on these kind of remote routers. We don't access them every day. It turns off the Bluetooth, it turns off the serial connection, and it only lets you hit it over the mesh with the PKI admin. So essentially we're kind of hitting the close it up, hitting the lock itself out button, and we walk away from it. And to get it back, you just reset it and reflash it again. It takes like 5 seconds, but it kind of keeps it more safe when you don't have physical security of it.
Also saves a bit of power.
Does save power, turns LED lights off and the Bluetooth radios. And also like probably camouflaging these nodes if it's in like a public area. So like I don't know if you see this one's kind of real spray painted green. Kind of keeps it of the eye line there.
Yeah, all the ones we put up in hills now have Rust-Oleum green paint on them.
Yeah, right, exactly. So real world range, this is just from our testing in Maine, it's line of sight, it's UHF. So the higher the node, the better. Height is might. In my testing, you get about a quarter mile when you're on the ground around houses and trees and people and buildings. But when you get up high above all those obstacles, you get 15, 20 miles. During lifts, we made a connection. Someone went up to the top of Mount Washington last weekend and it connected like everybody. We're hitting people in the seacoast of New Hampshire, up here, and I live in Raymond. I think we hit you guys in Leamington. Yeah. So getting it high is cool. And also people flying like little Cessna airplanes and transmit. It's like a private pilot. And we've gotten some of that too. And that we saw people in like Rockland to coastal Maine, Augusta, when someone flew their plane just right. Of course, using external antenna when you're in your car or building is really important because the 915 is not going to penetrate through your car. And then flying a node on a drone or a balloon extends very significantly. So we've tested some lifting of these little nodes with a cheap DJI drone, and it worked really well. We're able to connect, and that's kind of I've seen in other states some public service like police and fire will use Meshtastic as like just a super backup link. I'm not sure what they're doing with it, but I saw one scenario where they would do a drone lift in like a wooded area to help first responders echo their location back so they could track where people were. Here's an example of a range test. In this case, this is me. I had a node on my rooftop, and then I went up to the top of Hacker Hill in Casco, and I was able to connect. This is my first long range Meshtastic connection. Like last year, I was super happy about it. But it did take getting up above the trees to make this long of a connection work. If we were just standing on the ground, it definitely wouldn't. But that being said, once you get something high, having 1 point high, 1 point low, kind of like a cell phone tower, kind of extends that range a lot. So right now we have a node up in a high part in Raymond, and it's about like 850 feet above sea level, and I can drive to like the Home Depot parking lot in North Wyndham and totally hit it. Sometimes it can't hear me, but I can hear it, right? Because I'm trying to transmit with low power somewhere that's a little obstructed. So you can definitely hear the router. You can't always talk back to it. This is an example of saying a router at altitude. So like this is some real mapping here. This is me. We have a router kind of near Black Hat, and then these are some guys in Gloucester and Gray, and we're able to bounce off the router really nicely and talk to each other very consistently. Here's another example of that same router. I believe that's a pound of location, and that's New Gloucester, and that's Gray. So this is more topographical. You could see kind of how it falls. This is like the red is a coverage map, so it's looking at the theoretical coverage of the 915 from that location. And I found it's pretty accurate. Like if you go and stand in the red spots and you're above the trees, typically you can hear it. And this is an example of the drone lift. So here, this was like me in my yard. I flew my drone, and instead of everything jumping off the router, it hit my drone first and then went out. I don't know who the 6F50 guy is. He's out on your way.
Yeah,
I still haven't figured that out yet. Do you see him?
I do,
Yeah. He's on the public map, so he must be connected to the internet.
Never responded.
Yeah. And this is your router, right, guys?
Yeah.
58. Yeah.
It's not 05, yeah.
Yeah.
Yeah, the GPS is a little off.
So we get a lot of lifts. And especially at night. And I'm not a ham, you guys are, so correct me if I'm talking out my ass. What I believe, and I think what we've talked about when I've researched online, is this is happening from tropospheric ducting, and kind of explains how it works and whatever. So this is an example. I made a contact all the way down in almost Baltimore one day, and I looked at this tropo index map, and it lines up pretty well. And it kind of seems like, when we get those like hot days, cold nights, we see the lift. And probably tonight we're gonna see all these people in Massachusetts and New Hampshire. You can't necessarily talk to them. So there's this capability of trace routing on these devices, so you can ping someone and get a response back and see the hops it took to get there. Usually we can't ping the people that we see far away. I had someone, there's a lot of social media, there's Discord, Facebook groups, Facebook messengers for Mesh in this, New England. And someone's like, hey, I saw this message from Maine and it was me. And they saw it in Manchester, New Hampshire. I'm like, well, that's wicked cool. I couldn't talk to you, but you could hear me. And then also sometimes it's someone on a mountain or someone on an airplane. This is an example, this Adam 241, someone decided to hike out Mount Washington with a node. I think it's about a month ago, and he connected all of us. You can see the big rectangle here all the way down to Massachusetts. And in that scenario, we could talk back and forth and ping people in Mass and New Hampshire. So if anybody wants to put a node up in Mount Washington, you know anybody.
And like decently often we'll see people that are on like commercial flights, like just Delta, and they'll be like, I'm on Delta 689, and just like flying over
Yeah.
and just sending out messages and just seeing people watch him as he goes.
I don't know if I try to carry this through airport
Yeah.
security.
This one's at least a little easier.
Yeah.
I'm going to the West Coast in a couple weeks, and I'm gonna try. We'll see if I get some. Propagation mapping tools. I showed you some maps before. I use this heywhatsthat.com, and it gives you, if you're familiar with that, it gives you panoramas, which is cool. So it's like, this is where you are, this is your height, it'll show you all like the peaks and summits around you to kind of do your line of sight planning. It also has this WISP tool thing where it lets you build those coverage maps. So, this is where it's going, this is the height, this is the frequency, and it'll build your coverage map. This tool is cool. It's actually from someone in Maine and Camden who developed it for a wireless internet service provider like 10 years ago. And it's online, it's a free tool, and it's very helpful for this kind of mesh planning. And of course, you guys have probably all used the RF line of sight generator. We just use the LiDAR data to see if there's any obstructions between 2 points. And then the radio mobile online is also a go.
That one's really fun because you put in its frequency and antenna gain pattern. It really gets down to the weeds for generating the maps. And these are also great for 2 meter, 440, anything else that's line of sight in half space.
This is an example of using those tools. So in this scenario, I wanted to connect from the Dodge Oil, the Route 11 302 intersection in Naples, back to my house in Raymond. This is theoretical. So it's like, how do I do that? I'm gonna use this panorama tool to figure out what's a high point that those two places share or can see. In this case, it's Hackers Hill. So hey, let's put a note up on Hackers Hill. From there, I'm gonna use the coverage maps to kind of model what would it look like if I put a node up on Hackers Hill. In this case, this is the coverage I should be able to get doing that. Now, again, this varies. If I'm standing on the ground right next to a building or in a group of trees, I'm not going to connect to this. But if I'm out, in a field or in a clearing, it might, work a lot better. And this is kind of how to use that. This is all from that heywhatsthat.com website, how to use it. And this is using the line of sight. It's just verifying, are these 2 points going to connect and see each other? Again, access and physical security of the devices. You want to make sure that your nodes are mounted as high as possible. So you get the height is minus the line of sight coverage, but also physical security so people can't grab them if they're in like a more public location that you have permission to use. Yeah, permission should be obtained to place these. You probably shouldn't go throw this up places you're not supposed to. The node should be placed in an area that can't necessarily be easily accessed so that you don't have tampering, but you also want to be able to get it in case they fail. In our testing, they fail, I wouldn't say semi-often, but we have a lot of like firmware hiccups where a node will go offline. I don't know, like I had this one up for a year, and eventually the firmware got really old and just kind of crashed. And I flashed it and it came right back up. But that being said, I just needed a ladder to get that down. But if I had it like thrown up in a tree and I couldn't get it back, that wouldn't be ideal.
We had our router node when the trees grew in, and then it no longer had enough power. It kind of kept getting to a boot loop, and it boot looped itself enough times that it just wiped itself back to factory defaults. So then we had to go up, and I of course wasn't expecting that, so I didn't bring my documentation. So I just had to like re-provision the entire thing just from memory, which is the perk of building the documentation. Is at least I went through most of that.
I got to carry the ladder.
And this is an example of connecting two router sites. So we're struggling with this right now. We can't connect to save our lives. They're in Leamington, I'm in Raymond. We've been trying to point our stuff, move our antennas for about like 60, 90 days now. We can't talk to each other. So, you can do things like deploy a more directional antenna like a Yagi or a log periodic, try to get more line of sight connection there. This is an example of like, hey, Douglas Mountain is between me and you guys. Maybe that would be a good spot to put something. Except I did try that. I walked up with that stone tower and I could not. I still couldn't hear you guys. So more to come there.
And as a note for like placement specifically, so as we said, you only get 7 hops. And if you're already using a device in your house and then you have a device on your roof, that's 1 hop going out. Then you go off to a repeater, then to a second repeater. You're already at 3 or 4 hops by the time you get to your buddies, if they're close by. So we don't want to, smother the entire state with a node on every hillside either, because eventually that will just kind of smother out the sharing across. So we've definitely learned that node placement via the mapping and the line of sight charting is important. Node placement with a line of sight mapping and making sure you can also connect to your friends while you're standing on the ladder is also important.
Yeah.
Because the ladder gets heavy when you have to climb it back up there a few times.
For example, this week I just slightly repositioned a router that was up on top of a high spot, and like I moved it 40 feet southwest, and all the guys were like, "Oh my gosh, I don't know what you did, but like we can hear this so good now. Your SNR is way higher, so it matters for sure where that is."
And when you're doing the trace routes, which was mentioned earlier as well, I come from a networking background, so trace routes a regular thing that we do. You can see the signal strength, the dBs in between the nodes. So like I can see that me going out to the router, knowing that my house is not terribly good line of sight wise, I'm hitting it at like a -14, but then I'm hearing it back at like a +10. So it's in a good spot, but for me getting in there with all the foliage, with everything, is a bit rough. But I know that with a little extra power, some extra stuff, I can make it work. So using those, the trace routes while making changes or soon after changes or during lifts or whatever, it's very, very helpful tool. And it logs all of those that you send off to different people in the app itself not necessarily on the node, but in the app. So you can go back and look at the history and you can see, I did 2 of them last week, move the node, do 3 this week, and then I can see all the changes there.
Is that information like in every packet about the signal to noise ratio, the node
It is.
that it was?
It's not in every packet, especially because they have to fit as much data as they can into really small packets. So the trace routing that we're talking about is kind of a separate thing that you go when you click on the node, you hit the trace route button, you wait.
And so it'll send out a specific type of message.
Yes,
from
yeah.
them.
I think too, the position exchange, you can say share positions and it'll swap that one does SNR. And I think if you direct message someone else, it shows the SNR.
Yeah, and if you'll see in the settings for your device, they'll be like, how often do you want to exchange positions with people? And like you set it like interval 15, 30 minutes. So it'll like you'll see like an SNR value. It's not every packet, but every 15 or 30 minutes, it's gonna update that for things.
Yeah, there's a lot of heart beating, kind of like
Yeah.
AS8.
Yeah, we have a little demo we'll show you with mesh sense where you can see the heartbeats and the traffic come through. So troubleshooting, why is my mesh not working? If you go online, some people be like, Meshtastic is the stupidest thing ever, it does not work. And that's true if it's not deployed correctly. I think the biggest kind of gotcha with this is it's sending packets, it doesn't care if they get to the other end, it's just gonna send them. So you might ping someone and you might not get a response, but that person hears your ping. I talked about that Manchester story. They were hearing my messages. I had no idea, I couldn't even see them, but they were still hearing them because it's, it's just setting them all out, flooding it. So kind of the first thing, limited bandwidth. LoRa is optimized for range, not throughput. So only small packets can be transmitted, causing delays in incomplete data propagation. This next piece, I think, is the key as to why people say this doesn't work, is that network latency congestion. Nodes may queue up and drop messages during periods of high traffic or poor link quality. And I think that's our biggest gotcha out here is the poor link quality. If you're not getting everything, it can't tell. You can't tell. It just looks like it's not working. But really, I think you're not really receiving the packets. Unreliable node discovery. So unlike like a IPv4 router or something that has like a stateful table where it's like keeping track of everything. These are just showing you the recents. Hey, in the past 30 minutes, these are the nodes I saw. It doesn't have like a database where it's looking. It's like, oh, well, I saw this last Wednesday and this was the thing. It doesn't have that. So that table, that kind of live little glimpse of it gets a little obstructed sometimes. Device variability. There's a lot of different devices, and of course, antennas and coax and pigtails, all that goes into play. I'm sure, as radio people, if your pigtails not working or it's messed up, or it's not able to send the radio signals through effectively, then it's not going to work. There's a lot of variability to this, unlike a cell phone where everybody has the same thing. And then, of course, environmental interference, physical obstructions, weather, RF noise can all degrade that signal. I don't think we put anything near like a big commercial transmitter yet, but I feel like we might start getting some interference somewhere like that.
You can get bandpass filters for the 915 band. So if you're like I'm putting one on my home node eventually because it's right next to my 2-meter antenna and it can't hurt. And also if you live down the road from an FM station, probably can't hurt. And they're like $40. I've seen a lot of people say that helps quite a bit, especially in busy RF areas. But also, out here, it's not particularly busy for RF.
Right. And a quick note on the limited bandwidth. The messages that you can send are a max of 200 characters. So, they're small packets. So that's why, as we were saying earlier, it doesn't necessarily have the space, literally the bandwidth, to add the extra overhead into those packets. That's 200 characters. Of course, you can send as many as you want, as fast as you can type them, but
yeah,
it'll take its time and queue them and go. But
yeah, in my little mesh segment of the world, we have every 12 hours we send out like the National Weather Service forecast for the day, and it's like 2 sentences about the weather, the temperature, the whatever. It's gonna rain or slightly cloudy, and then that sends out every 12 hours. And it gives us a heartbeat. Hey, our network's still working because we expect these messages to come through at 9 a.m., 9 p.m. And also, makes sure it's kind of still there. And we keep those truncated for that purpose of the small message size. Trace routes, this is what we're talking about. So if this is like when we're trying to troubleshoot or test things, trace route is kind of the go-to. So here's an example. I wanted to trace route to this guy SAB2. And you can see that's an example of all the information you get from the kind of mesh peers. You see their name, the last seen date, time, the role that device is running, client as it should be, how far away it is based on location. You can see logs from that device and how many the hop count from you. All that information is shared on the primary channel. There'll be multiple channels. And the default is long fast, which is kind of the open public one. And that's what we have everything set to, is so we can see this information. If you have like your own private channel or private channel with a friend as your primary, all this data is going to be invisible to the rest of the mesh because you're not sending it. So in this example, you're gonna hit trace route, and it's gonna give you this nice little report back. And so you can see the hops directly here. I went from Charlie 1, which is my rooftop node. It went to the repeater, which is, sorry, Charlie 1 is my client inside. This is this guy. It went to the repeater, which was on my rooftop. Then it went to another repeater, which was at an elevation, and then it went to the final destination, which was SAB2. And you can see, between in my house and the repeater, it doesn't have that information because at the time I didn't have those nodes on the same channel, so it couldn't see the information back and forth. But I could see it with Whiskey 2 because he was on my same channel as my sending node. So I see, -3 dB between the repeater and the SAB2 guy, and on the way back it was 12. So I could hear him way better than he could hear me. And here's an example of the topology in that case. The source was in my home, hop 1 was on my roof, hop 2 was the repeater, and the destination was hop 3. But of course, it's 2 hops because the source and the destination don't count on your hop count. This is more troubleshooting like from your device, your client. This max transmissions reach, that means it couldn't see anything. If you're getting max transmission reach, it means nothing can hear you. So let's say, hey, my node isn't talking at close range. I have 2 nodes and they can't hear each other on the same table. That means that my LoRa settings, or like the modem settings, are different. Maybe one's on frequency slot 4 and one's a frequency slot 20, or one's on long fast and one's on, what are the other ones? Short, medium fast, whatever, and they can't talk. So that if you're trying to test, you're doing like a sanity test and you get 2 next to each other and they can't talk because the LoRa settings are different. If they can't talk at long range, it's usually a line of sight issue or like an antenna, a coax feed problem. And I had the troubleshooting step here is try them at close range. If they work there, then it's most likely a line of sight problem. If the node isn't reachable by Bluetooth, which means you pull up the app and it's not showing up to manage, chances are it crashed and you have to reflash it. And it's 30 seconds, plug it into the computer, pull down a fresh firmware from Meshtastic web flasher and redo it. Luckily, the configuration on these isn't bad. It's if you have like your encryption keys saved and they're in the form of QR codes, I just like save the QR codes in like my secure notes app on my phone. I just reference back to those. It's really easy to rebuild these things. And then finally, if it's not functioning, the lights don't turn on, you plug it into your computer, it's not coming up, you just factory reset it, you hold down the reset button, I think it's 20 seconds or something, and then you reflash it. So it's kind of when in doubt, reflash it if it's a firmware, like a response problem, the device when you're trying to manage it locally.
And I've put a little effort into being able to do that via Android as well. I actually updated my green node there before I left the house today. And I literally just downloaded the file onto my phone, unzipped it, and like you double-ended USB cable, plugged it in, and like put it into DFU mode. It pops up as a little storage device, and I literally hit copy into there, and then it reboots and it comes up on the new firmware. Literally, I can do that from my phone.
Nice.
So
That's sweet.
iOS not as cool.
No,
but
Put text messages.
that's how you know you're cool. This is how to set up that. We talked about the PKI admin or the remote admin. This is how you set it up. This would be like the remote device you're trying to administer, and then this would be the device you're administrating from. So like the one that's like connected at your house or on your computer or whatever. The remote device you're trying to connect to, you're putting the public key from your administration device into these admin key settings in the remote node. So you can have up to 3 administration devices. And then to actually do this, so like let's say this is a router up in a tree 10 miles away, I have my key for my node that sits on my desk. I would put that in here, save it, deploy my node, then I can go home, and from my configuration screen, I can look and see which nodes I have set up for PKI, select it, and then it's going to be able to pull down the configuration over the mesh. However, this little yellow message is usually what I get when I try to do this. All it says is, the LoRa configurator is requested via PKC admin, but no response has been returned from the remote node. If it's on my desk right next to it, usually it works. So I think it's a transmission issue. But that's not helpful. If I can touch it with my hands, I don't need to manage it over the mesh. Additional tools. So these are some things we found really helpful in deploying these. MeshSense is a Windows and a Linux and I think a Mac application. You connect it to a node and it's kind of doing everything the client is doing, but it's gonna, I have a demo, but it's gonna show you all the traffic that's happening on the mesh in that moment. It's gonna draw a nice map and do the vector lines to show you what connects to what. Sometimes it guesses on the vector lines and things will come out a little different, but if you have like with us, with our remote routers, we want to be able to use this data to see the health of the network. We make sure we set the location properly so we can really get a good visualization of where this stuff is. Meshmap.org is like the global map of everything connected to the internet. There's this protocol called MQTT, which is kind of what translate Meshtastic messages to the internet kind of interfaces, where you can say, hey, I want to expose all of my Meshtastic data to the internet so everybody can see it. We don't participate in that because that's kind of not what we're going for, but you can see a lot of other people in the area. And then finally, social media. Meshtastic is new and it's fairly popular amongst like guys like us, but it's not like super popular. So there's not a ton of documentation on it. So like YouTube videos of people actually using it, troubleshooting it. Social media where people are talking about, hey, I'm having this problem. Have you seen this? What do you think we should do? That's all really helpful. We've recently gotten on Discord with the New Hampshire and the Mass folks, and they've been really helpful with how they've done things, problems they've come across, that kind of stuff. What else we got here? Other ideas. Dakota's talking about there's a whole suite of sensors for the rack boards. It's like motors and storage and wireless and power and display and a whole bunch of stuff you can do with the rack platform. Meshtastic is just one of them. You can use this. I think you talked about the ATAC integration.
Yeah, which ATAC is it's sort of like a first responder, military, and like sort of backcountry app that's got like a map. You can say where your friends are and say, oh, hey, I saw a deer here or whatever. And I've played around with it a little bit, but not too much. But normally it just runs on your phone, needs a cellular connection. But if you're in backwoods, obviously don't have that. And there's a plugin for ATAC that will, if you have your phone connected to one of these guys, will route ATAC over that. So, say you park your car at a high point with a router node on it, and you and all of your buddies have, your Meshtastic nodes in your phones, you can mark out like, oh, I have a campsite here. Oh, there's a tree fall here, whatever you're working on. So that's something to, play around with. And, you can, especially like, I think that's the first responder thing you're talking about out west. I think that's what they're using because that's pretty common.
Yeah. There's
actually, last, I think like 5 or 6 years ago, there was a similar system that was a commercial system called GoTenna. That was aimed more at hikers and first responders. That was using essentially the same hardware as this, but it was way more expensive than a paid service. And it was built to do kind of the same thing.
And then other ideas like, you could make this part of your pace plan. Maybe, you can, once we get a big enough mesh network, you can throw one of these in each of your cars or whatever. And it's like, hey, if the cell phone network ever goes out, you can have a way to connect with your family members. We talked about like, hey, how do we, I want to get an alert if someone opens my box out, out in the woods, so you can put a tamper switch. Or we even talked about like, there's like a light sensor inside for the racks. You can put a light sensor in your box. Someone opens it. Hey, the light's turned on. Someone's trying to get into my box.
Tamper switch will be handy for case where the Ossipee Hill Fire Tower. I know the guy that's the caretaker of it. He keep breaking into the cabin.
Yeah.
That I could alert him.
So that's a really good transition into like what this is IoT, right? That's what this is we're putting little low power devices out anywhere and to transmit information. It was kind of done as like a crypto idea, but it's like they would send you these miners. And it was LoRa. It was a LoRa gateway. You plug it into your Wi-Fi. It had a little antenna in your window. And they were trying to resell that network to enterprises for like their like CMPs, power meters, and like the tracker sensors on like rental bulldozers or whatever. And they were trying to get people to install these in their homes so they could expand their network for the purpose of backhauling stuff.
Are you talking about Ilium?
Yeah. Yep.
And as a note too, like this is, it connects to an app on your phone. It's a device you throw in your bag with you and you go about your day. Like you do need to set up the infrastructure and do the things, the nerds like us enjoy that sort of stuff. But it's also a really good kind of connector in between folks that aren't radio based. And it's just like, just carry this in your pocket and use your phone. Like that's pretty easy and a pretty good intro to getting other folks into it and doing those sorts of things along the way.
And it's
Yeah.
nice and cheap, and you don't need a license to get started, and it gets people interested in it. So, a couple $100, you can have a whole, high school class playing with these things, and then all of a sudden half of them are interested in getting their tech licenses.
That's my current path. This has gotten me on the ham radio.
Yeah.
Dakota's been bothering me forever. What else we got here? Additional resources. These are just some things we found really helpful. The comms channel on YouTube, great Meshtastic series. Ham radio crash course. That guy has good information. Meshtastic.org. Rockland is a good place to source the hardware. Rockland does sell on Amazon, and we've had good luck with the Rockland hardware we bought from Amazon. Just make sure it's from Rockland. And then this is like the primary Facebook group. That's the biggest in that we see, and there's a lot of good stuff there. And then this is our mesh. We have a main network, a main channel that we kind of talk on and play on to test with. This QR code, if you scan with your phone, it's going to try to open up Meshtastic, and it has all the information for the channel. So the name, the encryption key, we have it open because it's kind of supposed to be public. But this is how you share channels with people. So let's say you wanted to create a private channel with your family or your friend or some buddies in the area. You create the channel on your phone, then you generate a QR code, and that's how you share that channel with each other. And the QR code will contain that AES 256 encryption key.
And if you just take a picture of this now, you can
Yeah.
store it and then just press and hold it later when you have the app and it's all connected, you can just add it right in.
Also, if you just search on Facebook for Maine Mesh, we have a group there. In the mesh testing documentation, I have them add a link to our stuff as well. We're using a GitHub site as sort of a landing page to route all that out, but also to store documentation and code if needed.
I've been putting a lot of work into the documentation. I haven't fully released it yet. So that's on my docket for the next little bit, is to get a lot of that, just like default configs and like some of the like specialized stuff that we're going to be doing up here. Just so that we kind of have a standard to build off of. The kind of the point of the mesh is that everyone gets to kind of do their own thing, how they want to do it. But as I mentioned, if everyone puts a router on every hill, then we're kind of, flooding ourselves out. So there does need to be some amount of coordination, which can be done, via the Facebook page, via the mesh, via whatever. So that way we can kind of build together. But then if we have the standards that are documented in a regular place, that'll be a good way to go. And like, this stuff is ever changing. Like we started this, 2 years ago, and we started on extra long, extra slow. Because we're like, I don't even know if this is gonna connect. So like we've come a long way since then, and it's gonna be a live document where things are gonna keep changing. So you may go on there and find that there's nothing today, and I might throw everything on there tomorrow, and it'll all change by next week. So
There's also,
check back.
in the last probably say 10-12 months, there's sort of been a critical mass, especially with the Rockland providing the cheaper hardware and all, where New Hampshire and Massachusetts have some pretty robust mesh networks now that we're starting to link into. So I feel like more and more people are getting involved in this, and it's like a pyramid scheme. If everyone
Yeah.
buys in, it's gonna work out.
Yeah.
And like these, we like made some things and glued these in, I 3D printed some parts. This whole case here that I'm throwing around, this was all 3D printed. This one's 3D printed. This guy I just bought, it came and it showed up and I charged it and connected to it. And that's the one I carry 99% of it. So it's also getting more accessible for regular. So,
Yeah. As far as cost, was that $80 for this rebuild?
yeah, I think it was 90, and then I got a better antenna.
Yeah, I think this one I was trying to go for how cheap can I make this? Like the solar panel, the case, the battery was $15 and the board was 35. So I'm in it for whatever,
You can go to the
$50.
transfer station, find an old
Yeah.
carbon light.
Seriously.
Even like the station G2, the high-end ones that have a built-in LNA or an amplifier, those were $100 shipped. So
Yeah.
like nothing is particularly expensive for this.
And it's powerful. Like we can talk to people pretty well. We're still trying to figure out between us, but we got some terrain to overcome. But yeah,
Yeah, climb some more mountains.
cool stuff for sure. I think that's the end of this.
Yeah, we've talked for a while, so
Yeah.
it's
Good.
everyone's interested.
Good, thank you.
I have a couple of demos. I was going to show you Mesh Sense, then I was going to show you the SDR, the traffic, what this looks like, the chirps.
Mesh Sense is pretty cool too, because you can flip a switch and it'll go to a Mesh Sense like global map. That's helped a lot with routing.
So this map looks a little bit off because we've static locations set on our stuff. So like they're like all the rack stuff, there's no GPS module, so it only knows the location we've told it. Like for instance, mine still think they're at my house because that's where I told it they lived. BBJ, is that you?
Yeah.
Nice. So yours still thinks it's at your house.
It doesn't have a GPS module, and I told it to use my phone. and
There you
it
go.
Doesn't seem to.
Last time you checked in. I know for mine, it doesn't change until I go in and like go into settings, go into location and say update, and then it'll pull it. I don't know.
My green one has a GPS on it, but it doesn't necessarily work that well inside of the building. So,
This down here's all the traffic. So this is kind of live what's happening on the mesh, and we can see its position data. These encrypted packets are it's saying, hey, I see this encrypted packet. I don't know what it is, but I do know it's from Rock City, which is you.
Those are just like
There you go.
private messages,
You just
so.
messaged us.
Yeah.
And I'm using this Hell Tech as kind of like the listening device for the laptop so I can gather this data. So like I just got a message from Dakota and whoever else I can message, hello. And then also from this interface, you can talk on the network. So like here, channel 0 is the long fast default. So like if we talk on here, everybody really who uses Meshtastic is going to hear us. Whereas we have these other channels like our Maine Net and then some other stuff we were testing with. So like, let's say if I get on here and message on this FRQ Mon channel, no one's going to hear that because that's a private channel that only I have the keys to. And here's kind of more breakout of the data you can see about each node. It's like the long name, the short name, the last time you heard it, the voltage. You can look at the location, and you can also do the trace routes from here too. And the trace routes is how MeshSense figures out how to do the vectoring for the diagram here. That's about it for
You
MeshSense.
should pull up the global map.
Oh, yeah. Yep.
There's a world
This
icon in
guy.
the upper right hand.
So this is everybody who runs MeshSense and contributes to it. So you can see kind of
Oh, wow.
the larger mesh here, and it's going to be slow because there's a lot going on, but once it loads. So if that's John, that's me. We both contribute to MeshSense, and then everybody else in the world who does that. And honestly, this is really popular in Europe. There's a lot of people in Europe who use Meshtastic. Yeah, and honestly, did it start there?
Yeah.
Yeah,
it was
I
a-
don't think it did.
It was a Swiss fella.
Yeah,
Yeah, I'd say it's probably on par in terms of saturation as like APRS is. Like there's, as many mesh nodes as there are digifeeders around now.
this is a custom website that the New Hampshire Mesh guys built. There's a couple devs in that group, and they have made a really cool interactive map. So you can see like they have their infrastructure, their routers to have different images. These are kind of live connections between. One time during a lift, we actually did get connected back up to us, and you could see it on this website, which was cool. And then these greens, these are people who are, I think they're MQTT, so they're publishing their information to the internet. So that's how this tool can bring them down. Like you can actually hear these people from New Hampshire, but they're on the map because they're publishing to the internet.
Kind of like Echo Link.
Looking at iGates and everything.
Yeah, yeah.
Putting new packets into them.
Yeah.
Injecting.
And then
Yeah,
that's
if anyone's ever done APRS stuff, this is very, very similar. Just cheaper and
this is like the global Meshtastic map that like the service itself publishes. So these are everybody who's contributing to the internet with their device. So this is cool to go on and see like, hey, is there neighbors? Are people using this around me? These are good tools to see that. And then finally, I'm just going to show you what this traffic looks like. So I've got RTL, SDR.
We're shifting with when the Andy Kirby on YouTube.
yeah, I think it's, solving that, but Meshtastic's established and there's a few other options,
Is
but
that you?
Yeah.
So it chirps, right? It's what this is sending is little bursts of data. And that's what it looks like for messages, for broadcast, for positions. If you're into like signals intelligence and you wanted to figure out like, hey, is there Meshtastic around me on the other frequencies, other channels? Yes, you could set your devices to those frequencies and test and see who's out there. But you could also just tune to the different frequencies, or also these chirps have a signature. They're always the same kind of like looking packet. So you could kind of do some analysis just looking at the radio traffic to determine if people are using Meshtastic around you or any other kind of LoRa system. That's what I got.
Very cool. Is there a Meshtastic plugin for the AirSpy?
That's a great question.
I bet there
Yeah.
is, yeah, it's. If not, then someone gets to write one.
Yeah, that's a big packet. Bet if I fill my full character right here, I'll make the tropes bigger. Let's see.
Yeah.
Oh yeah.
And so on paper, it can resolve these down to, I think it's like negative 122 dBm. We've seen it go down to probably negative like 30, 40 and still get through, so it's pretty efficient. It's up there with like, like FT8 and all. Using all that computing power to, do math and pull things out.
Right.
Well, thank you.
Yeah.
That was very informative.
Amazing guy.
If you guys want to collaborate and build some meshes, let us know. We'd love to have more the merrier.
Well, I was just, while you were presenting, I pulled up my location to you based on the map that you're showing.
Yeah.
You based on QRZ,
Mhm.
and I'm like right in the middle.
There you go. Where do you live?
Standish on Chadbourne Road.
Oh,
in South Carolina.
Oh,
Yeah.
nice.
You'd probably help us connect.
Hey, you want a mesh node?
Yeah.
If you hook me up with a node, I will happily get it as high in a tree or whatever at my house as I can.
I've got like 2 or 3 spares kicking around.
Yeah.
We absolutely can connect to that, and then I was actually talking to Chuck Davis, who's on the call right now at the Ham Fest. He's on the north tip of Sebago.
Cool.
And so we were talking about the fact that if there was any interest from you guys, we might be able to add into that and maybe
Oh, yeah.
cover Sebago Lake pretty well.
Yeah.
That'd be-
I'm over in near Midas Lodge.
Yeah.
Let's run a roll call. What's your last name?
Baizley.
Beasley?
Baizley. Baizley.
Baizley.
Yes.
We're even getting folks that aren't here.
Oh, really cool. Saw a hand out there.
So I'm new at this,
Yeah.
so do I got the technician license, like a special license to use mesh?
Nope. I am not a licensed ham at all. And as long as you're transmitting under 1 watt, you don't need a license to use this.
Okay, so under 1 watt, I came here late, so the packets that this is sending is a very short amount of data. Can you send text? You said something about sending weather forecasts.
Yeah.
Is there a limit as to how many characters I can send in the packet?
200.
200 per packet, but you can send, like text messaging
Right.
years ago, like several messages across. So it'll queue it up. So for like a longer thing, like if you're doing a weather forecast or net check-in or something, you can, fill up your 200 characters, that message sends, the next couple hundred characters, that message sends. But otherwise, it's just like texting on your phone.
We have seen in testing, if you don't have a great connection, a short message will go through, but a long one won't. It's, hey, how are you doing? I get that through, but 2-3 sentences, it drops it.
I think the most popular message on there is testing.
Yeah, it really is. And that's just because of the nature of where we are in Maine with this right now. It's, us. We see a few people here and there, but it's kind of bleeding edge right now.
And like due to the low power, like what we could do in the winter, we couldn't do in the spring.
Yeah.
When the leaves came out. So once we get a little more power toward it, that'll definitely help a lot on that front. But
So I live in Gorham, I live on top of a hill.
Great.
So if, in order for me to see these messages, I would need a device like what you have down there hooked up to a computer or some sort.
It's the most common way to interface is a Bluetooth on your phone. So if
Okay.
you're in Bluetooth range of it, there's a Meshtastic app for your phone and you just connect to the device and like.
I can see it on my phone.
Yeah, I wish I could share my phone on the screen, but it looks like you're like using Apple Message. It's just, texting and then get the nodes list so you can see all the people in your area and you can directly message them, which is encrypted, or you can message in the channels like with a group. And the default channel is 0 long fast, and if you message there, like pretty much everybody can hear you, and that's how we do a lot of our testing.
Yeah, that's a public channel, then you
Yeah.
can make your own separate ones. And like I have my home nodes just in my attic for now. And if I'm sitting, downstairs, I can just connect to my phone and type into there. And if you're in Gorham on a hill, I'm one of the highest points in Buxton, so I'll probably be able to see you at least from there, so you could route through me to get to the rest of the mesh.
Yeah. If you guys want to coordinate our Facebook page, we have a couple other people we've just kind of met along the way and we're talking on there, Maine Mesh. Where else we collaborate with this stuff, but Signal, I think we use Signal to talk about this sometimes.
Yeah.
What if you don't have Facebook?
Yeah,
There's an email address,
There you go.
that's on the GitHub, I should check it more frequently, but I think I only ever had one email to it, but we can also do it over email or. You know,
Get on
just-
Mesh.
Or just join the mesh.
Are you versed in
Yeah,
Slack?
two T-beams sitting on.
There you go.
Project tape.
Are you versed in Slack, because we have a club Slack.
Oh,
That's that.
We should do a Meshtastic on the Slack channel.
yeah.
Yeah, well, I'll join that.
Yeah.
We've noticed a lot of locals use Discord. New Hampshire, Mass, they're all using Discord to coordinate their infrastructure.
Do you guys participate in the New Hampshire one? New Hampshire Discord?
Yeah, yes, we're on there. Yeah.
So is the typical setup, you were talking about, you have one handheld ones and a node outside, like a.
Yeah.
Outside?
Yeah, you
Right.
because we're in Maine, because of the terrain, you need one high. You know, you can shoot one to a tree with a potato cannon or put one up on your ridgeline if your house is high enough. I know like yours is on your ridgeline, but you're so low, you need to do a.
Yeah, you're in a hole.
Yeah,
so
yeah,
can't
I need to get
talk
I need to get a
you
little
meter.
further, but yeah, that's what these guys are for, so like,
You
basically.
put one of those outside.
Yeah, so like I have just that, or actually, mine's actually still one of these, because it was the first one I built, and it's just chilling on a pole on the side of my house.
Yeah.
With a like 4 dBi antenna on the side of it, so.
Yeah, like if you live in a high spot. I mean, obviously more height is better, but like I can take one of the T-beams up into my attic and my house is pretty tall and I'm on a ridge as well. And then I can hit some things like I used to be able to hit you intermittently in the
Until the
winter.
leaves came out.
Till the leaves came out, because it's solid trees. We're about 5 miles as the crow flies apart. But yeah, if you stick one on your roof, then if you can reach it by Bluetooth, all the better. If not, then just one to carry around and that'll route through.
Yeah, example of that is like I have one on my roof line and I was testing in North Wyndham. And like if I drove up to like, Seacoast Fun Park with like the sledding hill up there, I could hit it no problem. But then I like drove to like Walmart and I couldn't connect back at all. So that height is important. Until we get something in North Wyndham that actually does the coverage that can bounce from there, to the other routers.
Yeah, with a handful more routers, like say one on Blackstrap, where that computer is covered really well. If I had tower climbing money, it would be very tempting. But it's nice because, it's, other than occasionally going out and updating it as they're still developing a lot, these are pretty low maintenance. You don't have to run a feed line to it, you don't have to run power to it, just runs off solar and you don't have to think about it too much. My wife jokes that all my hobbies start looking like IEDs.
Yes.
I've had it propped up in her office on the 3rd floor. I've had it propped up in her window for weeks now. She's like, can you put that outside, please?
I had a drone dangling one underneath. What is that? You talked about changing. Last weekend, there's a vulnerability that came out for these from DEF CON, which is a security conference in Vegas. A developer there said, hey, I can impersonate these because you're not signing the packets correctly. And sure enough, we saw on the Massachusetts mesh, people's nodes were getting hijacked and that they're changing the names to like, this is insecure, don't use this. And what it was is that like, they were stealing people's like their hardware address and then giving their own different key and saying, hey, I'm this person impersonating the node. They did push a patch for it this week and we could patch all our nodes. But again, if it's up in a tree, you can't get to it, you can't patch. And this vulnerability doesn't really matter, but.
Yeah, and also too, like the keys that are already encrypted, so when you're using a shared, pre-shared key between you and your friends or whatever. That traffic was still fine because that was still encrypted and going through. It was really just the impersonation of like direct
The public traffic, yeah.
Yeah. So, but it's ever changing.
And you can see the chirps while we're talking. These are these guys talking to each other. Hey, I'm here. This is my location. This is my battery. Yeah.
Sweet.
Cool. So if you guys want like help or advice or you want to collaborate and setting some stuff up, let us know. We'd love to have participation.